Hello, in this video we are going to solve some exercises related with areas and volumes of similar figures, and we are going to widely use the concept of scale factor. So let's go ahead and start solving the first one. Um, One of the main things that you will use to properly solve these exercises is to recognize what information you have and what is being asked for you to find. So, like in the first exercise, you see that we have the values of three segments, and we are going to find another segment. So, since we have all of the four quantities same, all of them are centimeters, all of them are segments, um, so we can basically solve it by using a proportion. So let's write the proportion. Remember, a proportion is an equality between two ratios, which we can write as fractions. So let's begin with the x. X is to 7, remember, corresponding sides, like 2 is to 5. Okay? Remember, if we begin with a small figure in the first ratio, for the second ratio you should also begin with a small figure. Now we have this proportion, which we can solve either by solving it as an equation or with the rule of 3. So I am going to solve it with the rule of 3. So remember, rule of 3 is basically multiplying diagonal, 7 multiplied by 2, and divide by the remaining number, which in this case is 5. That would be 14, excuse me, 14 divided by 5, which is 2.8. Okay, so x is 2.8 centimeters. Okay, you can also solve it as an equation. I am going to do it just in case you want to also learn it by this method. But basically, you have like the same. Excuse me, I wrote it wrongly again. So we want to leave the x alone. So this 7, which is dividing, is in our way, so we need to move it to the other side. And since this is dividing, it goes to multiply. So it's x equals to 2/5 times 7. Okay, but since we have a fraction and a natural number, we can put a 1 underneath it and multiply it normally. 2 times 7 is 14, 5 times 1 is 5, and we get the same result, so x is 2.8 centimeters. Any method works, but you have to be careful because in the next exercises you won't be able to use the rule of 3 as you know it, because if we focus on this one, you will realize that, okay, we have the value of two segments, the value of one of the areas, and we want to find the value of the other area. In this case, we should find the scale factor. Okay, so if you want a straightforward way to do it, basically find the figure that you want to find the value of. In this case, we want this area. So then make the scale factor starting with that figure. So if we want the area of the big figure, let's begin with that one. So now we want the area. Let's take the segments, 8 over 5. That is going to be our scale factor. You can have it as a decimal, but again, it's always easier to work with fractions during the process. So this is the scale factor. Okay, what does it mean? That in order to get from this measure to this measure, you have to multiply it by 5/8. Okay, and now Knowing that, you will also need to multiply in order to get from this area to this other area. But since this is the scale factor of a segment and this is the scale factor of the areas, we need to square them. Okay, so we need to multiply by the square of the scale factor. So what does it mean? That 6.2 centimeters squared multiplied by 8 fifths squared should give you the value of A. So let's do it. 6.2 multiplied by 8 fifths squared is A. Okay, remember, you solve exponents before multiplications. So 6.2 multiplied by 8 times 8, 64. 5 times 5, 25 would be A. So you can either multiply straightforward or convert this fraction into a decimal. Let's do it. So 6.2, excuse me, let me write it outside the box. 6.2, now let's check, 64 divided by 25. 2.56 exactly, multiplied by 2.56. That should be 150. Ah, no, excuse me. It should be 15.872. Let's do it again, just to confirm. I forgot the point. Excuse me. So 6.2 multiplied by 2.56. Now it's correct value. 15 point, again, 872 square centimeters. That's the value of this area. Okay, now, what happens if we have the opposite value? Okay, what happens, sorry, not value, what happens if we have the opposite case? We have two areas and we want to find a segment. Okay, it's the opposite that from here. Here we had the two segments and we wanted an area. Here we have the two areas and we want a segment. So it's going to be quite similar. You need to find the scale factor. So if you want the figure on this side, let's begin with that one. The scale factor is going to be 75 over 48. But this is the scale factor of the two areas. So if you multiply it by 75 over 48, you will get this. Now, what happens if we want segments? Because in the previous exercise, we needed to make the second power, like we needed the square of the scale factor. Here, since we already have the areas, we need to do the opposite. Instead of square it, we have to find the square root of the scale factor. So it's going to be times the square root of 75 over 48. Okay? So, in this case, let's work with it as a decimal. I think it's more convenient since these numbers are quite big. So, 75 divided 48. 1.5625. Let's use the number without rounding it. 15625. Okay, then we need the square root of that, and that will be 8 multiply by the square root of 1.5625 should be x. Then let's do it. Square root of that. Wait, let's do it from the beginning just in case. Square root of 1.5625. We need to make the square root of that. Actually, I don't know. Is it? Nope, this is not. Let's use Wolfram. I don't know what happened with that calculator. Square root of 1.5625. Let's check. It's that one. Well, who knew? It's exactly 1.25. The other calculator was actually correct. So, 8 times 1.25. Yeah, exactly. And that should be 10. Okay, x is 10 centimeters. That's it, exactly 10 centimeters. Okay, let's continue. Determine whether the cylinders below are similar or not. Okay, so here we had a similar case than before. We had two measures of length and two measures of volume. Okay, so something really similar is going to happen. Look, here we had the length and then the areas, we squared the scale factor. But since here it's volume, and sorry, this should be centimeters cube, my bad, we have to find the cube of the scale factor. But the question is how to determine if they are similar or not. You could either find each of the measures here in order to find the volume, like finding the like with the volume you can deconstruct the formula and find all of the measures, like for example the measure of the height, but that's a quite long process. And since in this exam we wanted to use the concept of scale factor, we can do it using the scale factor. Because if the scale factor to get from the small measure of length to the big measure of length is 9/6, which is basically it's multiplied by this, which is 3/2. We just simplified. Then 135 multiplied by that scale factor but cubed should give you 320. Okay, let's check. So 135 multiplied by 3/2 cubed. Then this should be 135 multiplied by 3 times 3 times 3, that's 27. And 2 times 2 times 2, that's 8. Then let's do it. We can put a 1 underneath this and make 137 times, sorry, 135 times 27 and 1 times 8. Let's do it. 4,995, and then divided by 8 is 624.375. again, 375. So this should be the volume of the big cylinder. So since we didn't get the actual value, that means that the concept of scale factor doesn't apply here. And since there's not a scale factor that can help you converting from lengths to lengths and from volumes to volumes, that means that the figures are not similar. So they are not similar. Okay. Now, point 3. The triangle BCD, so this triangle that I am pointing here, has an area of 8 meters squared. And the trapezoid ABDE, so only this part, has an area of 12 square meters. Now we have to find the length of AE. Okay? And remember that we can find it if we have similar figures. Okay? And these triangles are similar because these two lines are parallel. And remember what we did during demonstrations. This angle is the same for both of the triangles, and since these two lines are parallel, this is corresponding to this one, they are equal. This is corresponding to this one, they are equal. So we have equiangular triangles, they are similar. So we can use the scale factor in order to find the measure that we want. Let's do it. But remember, let's draw the triangles completely. So here we have a measure of 3 meters, and this area is 8 square meters. And this one, we don't have it. Let's call it X. And this area is not 12 square meters, because this 12 is only the trapezoid here. What does it mean? That the triangle is 8 plus 12 meters, which is 20. So this is 20 square meters. Now we can find these because we have two areas and we have one segment. So let's find the scale factor. I am going to do it with other color here just to not get confused. And since we want the length of the big figure, then we are going to find this scale factor. Okay? So 20 divided by 8, that's the scale factor. Scale factor is 20 divided by 8, which is 5/4 by simplifying. Okay, that's the scale factor of the areas. So that should mean that if we multiply 3 times the square root of that, we should get x. So let's do it. 3 multiplied by the square root of 5/4, excuse me, 5/2. Excuse me, I made a mistake here. It's 5/2. Okay, we simplified by 4 and we simplify by 4. Yeah, this is 5/2. Okay, let's actually write this properly. Again, this is 5/2. Okay, because divided by 4, divided by 4. Yeah. Again, now if we multiply the 3 by the square root of 5/2, which is 2.5, then we should get x. So x should be equal to 3 multiplied by the square root of 5/2. Or if you prefer it in decimal, 3 is the result of the square root of 3 multiplied by the square root of 2.5 gives you x. Let's do it here. Square root of 2.5, and that, let's multiply it by 3. So this is the simple radical, like this is the input, and this is the result. 4.7432342, and it looks like it continues. So let's round it to two decimal digits. 4.74. Approximately. That's the value here. Finally, we get to the fourth point. I am going to do a different video about this one because this is quite long and we already have a 20-minute duration for this one. So check the next video, please.